we have here, Kevin's little mini bio, our cyber defenders must be ever vigilant because our adversaries only have to be lucky once in order to inflict great harm to our society. So please welcome Kevin.
So as Mr. Brewer mentioned, a lot of concern about cyber threats and some of the secondary and tertiary downstream effects if there was a dedicated cyber attack directed against Canada's critical infrastructure. I won't read to you this quote from the great military strategist Sun Tzu, but I'll let you look at it. But I will read to you some quotes from another great military strategy, Karl von Clausewitz. Clausewitz said, "Everything in war is very simple, but the simple things are very difficult." He also said the backbone of surprise is fusing speed with secrecy. And of course, his most famous quote, "War is the continuation of politics by other means." So thinking about the cyber threat landscape and what it has meant, even within the time frame of my own career, initially, the whole idea was hacking. If you were a member of the hacking community and you could target a government website or a big corporation, maybe you were opposed to some of the things they were doing, and you could deface their website, like perhaps put Snoopy dancing on it or something like that, you could then brag about it in cyberspace and sort of get some cyber high fives for being a successful hacker. But pretty quickly, this community and others realized that within those government and those corporate IT infrastructures were databases with intellectual property, blueprints, diagrams, future plans, things of that nature, as well as banking, medical records, and such. This led to the advent, of course, of cybercrime. And then, one of the world's oldest professions, espionage. During the Cold War framework, you'd have to send people in deep cover and trying to understand the order of battle, so to speak, of an adversary. What's the organization structure? What sort of plans for contingencies do they have? As well as corporate strategies, things of that nature. But what's happened now is those things are all kept in project plans online, so it's led to the advent of cyber espionage. And I think what we've also seen over the last few years, whenever there's a major kinetic engagement anywhere in the world, it's typically preceded, usually by just a few hours, with a massive cyber attack against things like command control, communications, computer systems, and I would argue moving forward, critical infrastructure. So let's talk specifically about what is the critical infrastructure components for Canada. So according to Public Safety Canada, they published the National Strategy for Critical Infrastructure, and they listed these as being the 10 critical sectors: energy and utilities, finance, food, transportation, government, information and communication technologies, health, water, safety, and manufacturing. As I mentioned, cyber attackers are getting, as proliferation of attack surface, introduction of IoT, Internet of Things, mobile devices, the adversaries are iterating just as quickly and developing specialized niche capability to attack these various platforms. And many of these platforms are critical to keeping critical infrastructure up and running. Here's a great quote from Director Michel Colomb of the Canadian Security Intelligence Services. And he basically talks about specific attacks, adversarial attacks, Canadians who have been disloyal to the nation, who've committed espionage. But Mr. Colomb calls out the concerns specific to cyber attacks and what sort of damage they can do to national security. Some of the risks are, of course, occurred through natural events. Things like, listed here, things like floods, massive ice storms, also some man-made events like September 11th, things, even medical things that can occur, like the 2003 the severe acute respiratory syndrome outbreak, the London bombings, and of course Hurricane Katrina, natural events. But there's a lot of recent evidence that shows that these types of threats are growing, especially the man-made components and things that also could be cyber-specific. One of the things I would add to this list, if you look at some of the trends in the legislature, Bill S4, if you're familiar with it, is the Digital Privacy Act. And the data breach component of it has not been passed into final law, but there are discussions occurring that if it is, the fine for a major breach occurring that's not properly reported to the authorities would be a $100,000 fine. So let's talk about just some specific critical infrastructure components and try to think through sort of war games, so to speak, what could be a lot of things that could go wrong. So if you think about traffic systems, right? It used to be vehicles had just simply their operations. Now, vehicles are essentially computers. I mean, there's tens of thousands of lines of code in any new car that you buy. There's also interlocking systems with traffic signal control, integration, let's say, with other things, law enforcement communications, weather pattern assessments, all these things that affect traffic modeling. So imagine if a dedicated adversary wanted to sort of meddle with and orchestrate an attack, especially during extreme weather crises, to throw some of these traffic control systems in place, what some of the effects could be for that. Another consideration, which is also part of Canada's critical infrastructure, is healthcare. So it used to be your data was you, your doctor, a few insurance companies, some labs, things like that. But what we're seeing now is patient medical records are just being diffused and proliferated in so many directions, it's absolutely mind-boggling. So let's talk about Canada's framework, ITSG 33, specific for how the Crown manages security risk. So there were legacy documentations, MG2 and MG4, so the ITSG 33 supersedes and replaces those. And it puts the sort of the framework around it at a program level and an IT project level. And I'd like to explain what the difference is. So if you think about the Project Management Institute, they differentiate between programs and projects. So rather than give like a kind of like a boring definition, I'll actually give some examples. So think about your teeth, right? If you're getting a cavity filled, that's a project. But good oral hygiene, where day in and day out, you're brushing and flossing, that would be an oral hygiene program. If you think about something like painting the Golden Gate Bridge, it actually has features of both, because once you get to the end of painting the bridge, the other end is already starting to rust. So you're completing a project, but you're constantly sort of iterating through to do that type of activity. And that's what ITSG 33 calls out, is this sort of approaches both at the project level and the program level. So it breaks it, the ITSG 33 breaks into classes of control families. There's specific technical controls. An example would be implementing, let's say, a firewall with specific, what they call ACLs, access control lists applied to it. Operational controls, which are things that would involve actually human activity to be involved. And then, but sort of like the worker piece, doing the work at the technical level. And then management, sort of the holistic approach, perhaps where you're at within your respective organizations, where you're looking at IT security and IT security risks and giving a sort of management framework. Once these types of control families are looked at, there's also departmental security controls that include security control profiles. So there's basically, you take from the ITSG 33, the security catalog, take the specific controls that map to a specific business environment. These are things that would affect the confidentiality, integrity, and availability needed to protect different tiers of sensitive Canadian data. And it's not a final say, it's actually used as a starting point. At that point, once that control framework and those profiles are put in place, the organization can then tailor them to specific business needs that they have. So can actually plus up the requirements in certain areas. And also if there's a certain rationale for, let's say, loosening a control. For example, if there's mitigating controls or there's other things in place to sort of offset, these things can all be considered. This is showing the Annex 1 and Annex 2 of the ITSG 33. And this shows the specific risk management activities as they're set up through different projects. The benefits to organizations that do rely on the ITSG 33 guidelines are pretty significant. Can give compliance with Treasury Board of Canada Secretariat requirements, can provide for assurance that all the aspects are being efficiently addressed. And what that means is, if you've ever heard the phrase mind the gaps, there could be somebody who's smart on cybersecurity, and they're just kind of going with their gut feel. Well, I know we need to do this, and they're deploying technologies and personnel. But some of the things that, in hindsight, after a cyber incident, might be self-evident. Like somebody might say, why didn't anyone address this? When in reality, it was something that was simply overlooked because somebody wasn't using a framework. So a framework provides sort of like a tactical overlay. Like if you think about, looking at you have a problem set and say, well, let's look at the lens of, this perspective, some other perspectives. So it brings it in, so it kind of helps you mine the gaps and to see where those sorts of vulnerabilities are. Also provides a cost effectiveness, so you could actually look at your cyber IT spend and make some decisions and say, well, it seems like we've really spent a lot of money and allocated a lot of personnel, a lot of resources to defend here, but a dedicated adversary can sort of do an assessment, sort of reconnaissance of our cybersecurity posture and look at these gaps that we have. So sort of, if you think about if you have toast, sort of spreading the butter, so to speak, on that. Also provides you with the ability to address stakeholder requirements, because anything you do and you make modifications or implement cybersecurity policies or technologies, there's probably consumers of IT services within your organization, and there's also Canadians out there that are citizen customers of this sort of technologies as well. So if you implement something, perhaps it is an excellent security methodology or security solution, but if it creates a lot of pain for those downstream consumers of that technology, what we find typically happens is those people are smart and they have technical skills as well, so they find workarounds. I'll give one example. Some organizations will block personal use email, things like Gmail or Hotmail. And what some employees will do, if they're taking, let's say, an online graduate course and they have a .edu mail address, they'll circumvent, they'll use it that way. If you say no USB removable media, well, they might simply send something to the printer and then scan it, send it out that way and change a Word document into an image. So there's lots of clever ways that users can do things like that. So the whole idea is about having also common terminology. Two people could both work in risk management, and if they're not using the same taxonomy for discussions, then you start to run into problems because a certain certain risk or vulnerability could be amplified or de-amplified, and then that's where misunderstanding can occur. And also just going through the whole risk management decision-making process to have interconnectivity between different critical infrastructure, IT infrastructures. So I'd like to talk a little bit about some of the approach being used by the United States government with regard to U.S. government federal systems and critical infrastructure within the United States. I'm not trying to say that the way the United States is doing it is the best way. Perhaps, for certain situations it is or it isn't. But what I'm saying is it is a way, and within the U.S. Department of Commerce, NIST, National Institute of Standards and Technologies, they develop these sort of documents and things specific to cybersecurity, and they publish them, make them available to the world. So I'd like to just discuss some of the similarities between the ITSG 33 and some of the things that the U.S. is doing. Both take a pretty good look at the holistic view of confidentiality, integrity, and availability of sensitive data and critical infrastructures. And both provide formal guidance that can, the whole idea, use it as a starting point, these frameworks, for building your cybersecurity, building or improving upon your cybersecurity framework, or simply, adopt it in full measure or partial. But it gives you sort of that foundational understanding. So both strive to do that. And then also both encourage you to address your organization's specific business needs. What are some driving cyber concerns for your organization? Both use control families and both provide standard taxonomy. Again, that's important for having good discussions. Where I see as the major differences between the Canadian and the American approach, ITSG 33, as I mentioned, does both project and program controls, whereas the U.S. documentation more has it in these control sets that sort of emerges the two concepts. The ITSG more crisply delineates the various control families between technical, operational, and management. And the ITSG 33 provides for these control profiles that I called out. So what does it mean in the United States, the concepts of FIPS 199, FIPS 200, and NIST Special Pub 853? Basically, within 199 and 200, they're complementary documents. And what they'll do is they'll assess the confidentiality, integrity, and availability, and they'll help the system owner go through a process where they'll tag that CIA triad as having a low, moderate, or high value. And just for sake of discussion, I'll give you some theoretical constructs around that. So within the US, there's something called the National Weather Service. They do a great job of notifying people in let's say, North Texas, Oklahoma, Kansas, what's referred to as sort of the hurricane belt, where a lot of these fast-moving storms, and there can be major loss to life. So let's think about the confidentiality of that National Weather Service data. Let's say a weather pattern is emerging very quickly that could have negative consequences. People need to take shelter in sort of these underground shelters because tornado could, did I say hurricane? I meant to say tornado. Tornadoes could uproot a home or a building, even flip over automobiles. So the confidentiality of that is not all that critical. If adversarial nations knew that the storm was brewing, they could use that to their advantage, but probably not, because they wouldn't have a lot of reactive time. The integrity, if that message is modified, if the storm is either overplayed, so people over-respond, or underplayed, they don't take shelter, that could have significant consequences. Also, availability. If you think about the availability, if that system went down, then there would potentially be catastrophic loss of life. But let's say, take another scenario, let's say there's a military system, theoretical here, right? Let's say it's a nuclear rocket system. If the confidentiality of that, the launch code information, was compromised, egregious harm, right, to national security. If the integrity, if it doesn't function correctly in a time of war, that's pretty important if somehow that system's modified. But the availability, if that system were knocked offline for, let's say, a period of 7 minutes before it gets restored, well, that just means the launch would be delayed at a point. So that's the sort of thing you have to think of for your organization, is the confidentiality, integrity, availability of the critical infrastructure. Where does it map to on that sort of triad? And then what happens after the FIPS 199 and 200 categorization occurs? You sort of have the framework then for the right security control. And then what happens is NIST Special Pub 853 comes into play. There's what happens if you lock up the bike, but you don't lock up the other components. So sort of that humorous illustration there with the bike, with the wheels being stolen and the handlebars. But 853 has these specific control families. It really can then, you can have, like I said, the low, moderate, or high control classes assigned, so you can actually have the right framework, right security controls put in place for that organization. That's pretty extensive. But that's mostly for U.S. federal government, although other organizations can adopt the 853 model. But the NIST Cybersecurity Framework is actually something that's being encouraged by the United States government to align policies and business technologies for critical infrastructure. It provides a framework that's more than federal standards for federal agencies, for commercial space, and for critical infrastructure. Allows for a little more in the way of flexibility and adaptability. And when this was being developed, there was a prodigious amount of coordination with the private sector. So Symantec was actually had a seat at the table when all of this was being discussed. But the whole idea around developing a framework, because it doesn't make any sense. If the critical infrastructure components owned by corporations, if they can't implement it or it's not appealing to them or it doesn't make sense for them, then it's simply going to become a recommendation that collects dust, right? It's just going to be sort of like shelfware. I think the battery is starting to slow down here. So what is a cybersecurity framework? Let's say what it's not. It's not a specific standard, it's not a specific set of controls, and it's not just a sort of check-the-box activity. Instead, it's a tool to help you to assess where you're at, your existing cybersecurity situation, on the sort of like what are the boots on the ground, so to speak, and then how do you incrementally improve on it. There's a concept in Japan called Kaizen, the idea of continuous steady improvement, so it can help organizations to sort of do that thing. And then if an organization is starting from scratch, if they simply, cyber was sort of an afterthought, if the operations people are simply deploying cyber tools and technologies, based on a gut feeling, it'll allow them to actually have a framework that they can wrap around and find where those, remember I said mind the gaps, find where those gaps are. Within the United States currently, it's completely voluntary, and there's only certain parts of the federal government that's starting to be mandated. And it's not meant to, it's not a rip and replace. It's not take the good work your organization's already done and rip it out. It's to plus up and sort of normalize the processes that you have. Again, having common framework, common taxonomy helps reduce cost, helps increase standardization and understanding. If you're hiring new staff and you're interviewing them, if you're speaking the same language, it's easier. If you're engaging industry partners or vendors, again, having this common language makes things work a lot easier. It also helps to identify and priority risk reduction activities. So as I mentioned, it was a collaboration between public and private, and again, the common language sort of create a cost-effective method for this discussion. And the idea is not to add additional onerous regulations. A lot of critical infrastructure was already facing various types of regulations and policies. So it's not, the idea is not to give them even more to worry about, but to actually help them to take the existing regulations and sort of have this framework to help meet those legal requirements. The whole idea is to allow the organization to understand what their specific risks are, and then what is their risk appetite as a business. They get to decide what sort of pieces are more critical than others. Like I know my organization. If this specific piece goes down for 5 minutes, it's not as critical that if this piece goes down. If confidentiality is impacted this way, well, that's okay. That can be public information anyway. But over here, hey, if this is compromised, my critical infrastructure is going to take a significant hit. So here's a sort of what the structure looks like, and it starts with a sort of everything comes with acronyms, right? So it provides specific codes. There's a function unique identifier, and it at least helps with this taxonomy. If you're doing, let's say you're hiring a third party to come in and do an assessment, they can sort of map to these function codes. But then it also spells out what is the specific underlying function, and then there's a category unique identifier code that can sort of explain what the purpose is. So it's helpful for auditing, helpful for reporting, and sort of provides this common taxonomy through the codes. So there's a sample here with an informative reference, and one of the great things about this is no new controls were introduced. So you've heard the saying, there's nothing new under the sun. So sort of what's happened here is that what they did was they recycled and they brought together existing controls from other standards. So they leveraged sort of best of breed recommendations, things from not just from NIST internally but external, things like COBIT, ISO, and also the Council on Cybersecurity